Good morning, class. We are looking at chapter 3, derivatives. Here, section 3.2, the derivatives as a function. So we looked at the derivatives and rates of change at a specific point, slope of a tangent line at a specific point, and now the derivative as a function. So recall, in the previous section, y equals f of x and point A and f of A gave us the secant line PQ and the average rate of change of y with respect to x. M, the slope of a PQ delta y over delta x, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or if you go with this format, f of x minus f of a is the rise, x minus a is the run. If you go with this format, f of a plus h minus f of a is the rise and h is the run. And if you have this pair with coordinates b comma f of b, then you have f of b minus f of a over b minus a. All of them are referring to the same thing. Now, as q approaches p gives rise to the red line, which is the tangent line, and the tangent line is the limiting position of the secant line pq as q approaches p. A tangent line is a line that touches a curve at a specific point without crossing it. And so slope of a tangent line, also known as instantaneous rate of change, we can say m of tangent is the limit of m of pq as q approaches p. Or if you look at this one, limit of f of x minus f of a over x minus a as x approaches a. Or if you look at this one, the limit of f of a plus h minus f of a over h as h approaches 0. And so these are various formats of defining it. And so ultimately we call it f prime of a, the slope of a tangent line at point A. Various forms of a line from standard form to point slope to slope intercept form. If we use the point slope on the pair a comma f of a, it gives us the equation of a tangent line y minus f of a equals f prime of a. M is f prime of a, x minus a. Now, do we have to memorize that? I would just simply go with the point slope. That is the fastest and easiest way to come up with the answer. And now section 3.2, the derivative as a function. We have considered the derivative of a function f at a fixed number a, f prime of a, is the limit of f of x minus f of a over x minus a as x approaches a, or the limit of f of a plus h minus f of a over h as h approaches 0. Now, we change our point of view and let the number a vary. If we replace a in this equation by a variable x, we get f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0, known as the derivative function. And so various notations, other notations. Given y equals f of x, then some common alternative notations for the derivatives are given as follows. F prime of x, y prime, dy dx, df dx, d dx of f of x, capital D of f of x, capital D sub x of f of x. The symbols capital D and d dx are called differentiation operators because they indicate the operation of differentiation, which is the process of calculating a derivative. We can rewrite the definition of a derivative in Leibniz's notation in the form dy dx is the limit of delta y over delta x as delta x approaches 0. A function f of x is differentiable at a if f prime of a exists. It is differentiable on an open interval of a to b, or a to infinity, or negative infinity to a, or negative to positive infinity, if it is differentiable at every number in the interval. So that's using other notations and the definition. Now, find an equation of a tangent line to the graph of the function f of x equals square root of 3x plus 1 at x equals 8. Previously, we would calculate the slope, in other words, f prime of 8. As you recall, in the last question of the previous section, I looked at a specific, not at a specific value, but at a, in essence, is similar to what we are going to do here. Instead of looking at it at 8, we are going to differentiate and then we plug in. The advantage of that is that if you want to calculate the equation of a line at several points, you have to do this only once. So let's find f prime of x first. And remember, we need two things. We need a pair. That means we're going to plug in here. And we need the slope. We're going to do both. So by definition, f prime is limit of f of x plus h minus f of x over h as h approaches 0. Following that, we're going to write f prime of x is the limit as h approaches 0. Fraction bar, the bottom is h. The top is the square root of 3 times x plus h plus 1 minus the function f of x. And we're going to work on that. Needless to say, if you plug in, you do get 0 over 0. So what is the technique? You're dealing with a square root. The technique is the conjugate, meaning the conjugate for a minus b is a plus b. Their product is a squared minus b squared. So the conjugate for the numerator, you write the same thing with the plus sign. You put it at top as well as the bottom, because this fraction must equal 1. So the top and the bottom must be identical. They are. And so a minus b times a plus b. First and foremost, what happens to the denominator? Absolutely nothing. You keep it as a product. Why? When h approaches 0, it is the 0 in the denominator that we should get rid of. That is the problem. Now, if you multiply the top, you follow a squared minus b squared. In other words, the product of these two becomes the square root of 3 times x plus h plus 1 quantity squared minus the square root of 3x plus 1 quantity squared, which means you write the denominator as a product and you don't distribute. The top, this comes out, and we get the limit as h approaches 0 of 3 times x plus h plus 1 minus the parenthesis 3x plus 1. As I mentioned, the bottom, you just don't touch it. We are going to distribute. We get 3x here, 3h plus 1 minus 3x minus 1. The 3x and minus 3x cancel each other. Positive and negative 1 cancel each other. And the numerator is only 3h. And notice h cancels out the h. And we get the limit as h approaches 0 of 3 over the square root of 3 times x plus h plus 1 plus the square root of 3x plus 1. And now it's important to keep the limit here. Now, because of the limit, you can replace the h with 0. And if you do so, the first square root becomes 3x plus 1, which is identical to the second one. Notice, now that we plugged in h equal to 0, we lose the limit sign, but not before that. And so f prime of x is this, 3 over 2 of that, 3 over 2 square root of 3x plus 1. Now, we need the pair and we need the slope. If you plug in 8 into the original function, you get 3 times 8, which is 24, plus 1, which is 25, and you get 8, comma 5. So that's the pair. If you plug it into this, the numerator is 3, 2 times. We said the square root of 3x plus 1, we showed it's 5. So we get 3 over 10. So the slope, m is f prime of 8. Plug in, you get 3 over 10. And the pair x comma y, plug in, we get 8 comma 5. Y minus y1 equals m times x minus x of 1. That means y minus 5 equals m 3 over 10 x minus 8. The right side, when you distribute, this becomes 3 over 10 times x, or 3/10 of x. And the product of these two is negative 24 over 10. Negative 24 over 10 is negative 12 over 5. We move the negative 5 to the other side. We make it positive 5. We change it to 25 over 5. With negative 12 over 5, we can add them up, and the final answer becomes y equals 3/10 of x plus 13 over 5. And if you plug in the pair, it does work, meaning this process is done right. It doesn't say anything about the differentiation. Again, I got to emphasize, we have to use the definition for this section as well as the previous one. As of the next section, we go with easy way out formulas. The graph of a function f is given. Use it to sketch the graph of f prime. How do we do that? Notice peaks and valleys, they create local extrema, maximum and minimum. And that means if you were to draw tangent lines at those points, would be a horizontal tangent line, the slope is 0. Over here and over here, the function is decreasing. That means f prime is negative. Over here and over here, f prime is positive because the function is increasing. So we use the information here. Now, we start with the easiest points. These 3 points are the easiest points. Those 3 points, if you were to draw, and those are peaks and valleys, if you were to draw tangent lines, would be horizontal, and you know the slope of any horizontal line is 0. Therefore, with the x coordinate of A, B, and C, the y coordinate must be 0. Those 3 points correspond to x-intercepts for the graph of y equals f prime of x. What about this portion? This is decreasing, f prime is negative. So to the left of A has to go below the x-axis for f prime. Here, the function is increasing and f prime is positive, meaning for over here, the graph of f prime is above the x-axis, so it has to go above the x-axis, but it has to come back down at some point back to B. This is B prime, back to 0, so it looks like that. What happens here? Again, it's decreasing. F prime is negative, so it has to go below the x-axis. But it has to come back up because, again, at C, or in this case, corresponding to C prime, must go back to 0. So it looks like this. And the last portion, everybody, of course, increasing. F prime is positive, and it must be above the x-axis, and it is. Now, this is sketch. It's a rough sketch. Now, what I want to add is the information about this point, and that is, if you draw a very careful line, tangent line, and pick up two pairs, calculate the slope. The slope is 3/2. What does it mean? At x equals 5, the y is 3/2 for f prime of x. 3/2 of 1.5. That's how they came up with that. And of course, putting them all together, here's the graph, everybody. So what about here? How do we graph f prime of x? Sketch it. If you happen to have a line, calculate its slope using the rise over run. M is delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Pick two pairs. Obviously, 0, 0 is the easiest one. And this is 1, 3. Please understand this is 1. This is 6. The scale along the x and y can't be, they don't have to be the same. So that's why it's 1, 3. So 3 minus 0 over 1 minus 0, the slope becomes 3. So for any line, if you want to sketch f prime, calculate the slope, y equals the slope, which is a horizontal line, is the answer. For any line, calculate the slope, y equals that, which is a horizontal line, is the graph of f prime of x. What about this case? Let's go with the easy points, peaks and valley. There is one of each. And those two correspond to x-intercepts. In between, the function is decreasing. That means this portion is decreasing. And so from here to here, it has to be below, but below the x-axis, and it has to come back up. The rest of it, this portion, as well as this portion, the function is increasing. F prime must be positive, and therefore, this must be above the x-axis, giving you the following graph. What about this function? Again, let's start with the easiest point, peaks and valley. There's only one peak, which corresponds to the x-intercept for f prime. If you look at this side, the function is increasing. That means f prime is positive above the x-axis. But this side is decreasing, f prime is negative below the x-axis. Put it together. So that's a rough sketch, fairly simple. How can a function fail to be differentiable? There are three ways. You have a corner, also known as a sharp corner, a discontinuity, a vertical tangent. A corner or kink, the graph of f has no tangent line at this point. The left and right limits are different. A discontinuity. If f is not continuous at a, then f is not differentiable at a. So at any discontinuity, for instance, a jump discontinuity, f fails to be differentiable. A vertical tangent, that means the limit of absolute value of f prime of x as x approaches a is infinity, which means the graph of a function f of x has a vertical tangent line at the point a comma f of a, if and only if, that means it goes back and forth. The limit of f prime of x as x approaches a is either negative or positive infinity. Both sides have the same result, meaning both sides have the same value, either infinity or negative infinity. On the other hand, we have something that looks like a corner, but it's a cusp. For example, at 0 here, the limit of f prime of x as x approaches 0 from the right is infinity, but from the left of 0 is negative infinity. Therefore, cusp happens when the graph of the function becomes vertical and then virtually doubles back on itself. Such pattern signals the presence of what is known as a vertical cusp. In general, we say that the graph of f of x has a vertical cusp at a comma f of a, if and only if the limit of f prime of x as x approaches a from the right is infinity, and from the left is negative infinity, or vice versa. Both sides do not have the same result. This one, both sides are either positive or negative. Negative infinity side, one side is negative, one side is positive infinity. That's how it works here. Okay. Example 4, the graph of a function f is given where and why the function is not differentiable. So this one, at x equals 0, there's a discontinuity. At x equals 3 is a vertical tangent line. And I want to quickly explain the difference between that and a sharp corner. So give me a moment. This one, definitely at -1, there is a discontinuity. At 2, there is a sharp corner. So what is the difference between a sharp corner and and a vertical tangent line? I hope you see that this clearly looks like a V shape. So it's a V shape or upside down V shape. This is not a V shape. So that's how you can distinguish between the two. But even if you think this is a sharp corner, the point is it's not differentiable. That's the main point. The graph of function f is given. Use it to sketch the graph of the derivative f prime. Now, notice you have a 1, 2, 3, 4 line segments. So if you just had one line, all you had to do, calculate the slope. So let's calculate the slope for each case. Therefore, let's put in some numbers. Assuming those numbers are right, we can calculate the slope using rise over run. So for example, for this piece, 0 minus 1 over -1 minus -3, the slope m becomes -1/2. Now, I hope you realize if this is -1/2, this m must be +1/2. -1,0,0,1, if you calculate it, m is +1, and this one, m is -1. I'm assuming no one has any problem calculating those pretty fast. So what happens next? Let's concentrate on the first piece only. We calculate the slope to be -1/2. For the first piece, we would draw the horizontal line y equals -1/2 if this line, this was a line which had a domain from negative to positive infinity, then this would be a horizontal line from negative to positive infinity. However, it stops here. So it covers only this portion. So this will cover this portion. And before we continue, I want to make sure we recognize that those are sharp corners. And so each one corresponds to a hole. So for this one, we have a hole here and goes to the left. For this one, so we write y equals 1, y equals -1, y equals 1/2. And for this one, it covers this much. Both ends must have a hole. For this one, covers this much. Both ends must have a hole. And for this one, from here, go to the right, and the left has the left endpoint has a hole. And that's the final answer. So we have 4 line segments, 4 slopes, and then we have 4 horizontal lines, portion of each. Find the derivative of the function f of x equals 5x plus 1. Again, I want to emphasize for this section, we have to use the definition as of the next section. This happened very fast using formula. So limit of f of x plus h minus f of x over h as h approaches 0. For this one would be the limit as h approaches 0, fraction bar. The bottom is h. F of x plus h is 5 times x plus h plus 1 minus f of x. So simply put, simplify the top. Needless to say, if you plug in, you get 0 over 0. So simplify the numerator as follows. 5x plus 5h plus 1 minus 5x minus 1. 5x cancels out negative 5x. Positive 1 cancels out negative 1. The numerator has 5h only. H cancels out the h. And the limit of 5 as h approaches 0 is simply 5. F of x is 2 over x. With this definition, we're going to write f prime of x is limit as h approaches 0, fraction bar, the bottom is h. F of x plus h is 2 over x plus h. If you plug in, you do get 0 over 0. We are dealing with a complex fraction. If you have a complex fraction, the technique is to use LCD, the least common denominator. So as you can see, there's one fraction here, one fraction here. X times x plus h is the LCD. We're going to multiply the top and the bottom by it. Now, again, I want to start with the bottom. Remember, h is approaching 0. This is the problem. You just write it as a product. You don't distribute. Now you distribute this over this. X plus h goes away. You get 2x. Minus x goes away 2 times x plus h. And again, we are not touching the denominator. We keep it as a product. So what do we get? Let's distribute. This is 2x minus 2x minus 2h. These two cancel each other. H and h cancel out. And now if you, again, you have to keep the limit here so you can replace the h with 0. If you do so, you get minus 2 over x squared. So f prime of x is minus 2 over x squared. Find the derivative of the function f of x equals 7x squared plus 4. We are going to use the definition. F prime of x is the limit of the fraction bar, the denominator is h, as h approaches 0. Now f of x plus h. 7 times x plus h, quantity squared plus 4, minus f of x. So all we have to do, simplify the numerator. Bear in mind, if you replace the h with 0, you do get 0 over 0. So what about this one? A plus b squared is a squared plus 2ab plus b squared. Therefore, this is x squared plus 2xh plus h squared. We put the 7 in front of it and we distribute. We get 7x squared plus 14xh plus 7h squared plus 4 minus 7x squared minus 4. So what happens? 7x squared and negative 7x squared cancel each other. Positive and negative 4 cancel each other. What is left in the numerator is 14xh plus 7h squared. We're going to factor the h out. The proper factoring is to take 7h out, okay? But because the denominator has h only, I want to just take the h out, which gives me 14x plus 7h. Again, proper factoring class would be to take 7h out. Okay. We are not going to do that. So we go that route, we get 2x plus h. But I don't want to do that because I just want to get rid of the h. So we have the limit of 14x plus 7h as h approaches 0. And now I can plug in h equal to 0. Please pay attention to the following. If the limit sign is missing, you can't replace the h with 0. The answer is 14x plus 7h. But because of the limit sign, that means you can replace the h with 0. The final answer is 14x. So the derivative of f of x is 14x, and we are done.